Hello students, welcome to Tuteetute. So many students are writing the mock test and some students are asking the doubts about these questions. So in this session we will understand the questions from our mock test. So first mock test, second mock test, and similarly, so next we will discuss about the third mock test also. So they have asked the questions about this power plant engineering because so many students have asked about this subject. So that's why I'm making a video on this one. So if you need any other subject mock test, our mock test explanations, video explanations you want, so just ask us. Otherwise, if you need any one or two questions explanation, just call our number. Okay, I will be clearing your doubt. Okay. So anyhow, let's see the questions from this mock test. So which type of alternator is employed in a thermal power plant? Okay, so we know already in thermal power plant or steam power plant, we are using the generator. Okay, so this alternator is nothing but a generator. So we are using synchronous generator. Okay, so synchronous generator, which is already we know. So it can be called as alternator. Okay, so some of the ECE students, they may not be knowing. That's why I'm just mentioning this. So the synchronous generator we are using. In synchronous generator, so we have two types. Okay, so one is a salient type. Okay, so salient type. Another one is a non-salient type. Okay, so remember one thing. So for the high-speed applications, okay, so for high-speed applications, non-salient pole type, this type of generator we are using. Okay, so this type of synchronous generator we are using. Okay, so remember the answer for this question is non-salient pole type. Okay, so here some of the other points also we need to understand. So in the steam power plant, this is the thermal power plant or steam power plant, what is the speed? So speed will be around 3000 rpm. Frequency equals to 50 hertz. So 50 hertz and number of poles equals to 2. So this also called as the turbo alternators. Okay, so synchronous non-salient pole type of alternators in the, so in this kind of power plants, okay, either thermal power plant or similarly nuclear power plant. Okay, in nuclear power plant also same specifications. Okay, so here non-salient pole type we are using, this also called as a turbo alternators. Okay, or high speed alternators are turbo alternators. Okay, so in hydroelectric power plants also we can use this non-salient pole type. Okay, so according to the speed of the turbine. Okay, so the turbine speed will be decided based on the discharge of the water and based on the head of the plant. Okay, so those all will be considerations here. Anyway, answer for this question is non-salient pole type of generator. Okay, and the next question, the indication to determine the incomplete combustion is, okay, so this is the question from the combustion. Okay, so combustion process. So how the combustion is happening? Whenever you send the coal into the boiler, so there with the coal we will be mixing the hot air also. So there it will be mixed and we have burnt that and the combustion will be happening there. Combustion is nothing but the firing. Okay, so we will be getting the flame out of we will be getting the flame, and from that flame we are utilizing the heat energy and we are converting the hot water into hot steam. Okay, that is our process. Okay, this we are doing in the thermal power plant, or so we are using in the similar kind of explanations is there for the nuclear power plant also. Okay, there it is no combustion but heat exchanger will be there. Okay, after the reactor heat exchanger will be there. Okay, so anyhow, here what is the consideration for the incomplete combustion? Okay, so that means combustion is not happening properly. How we need to understand? So we need to understand the two kinds of outcomes will be coming from the boiler. One is the bottom ash, another one is fly ash. Okay, so here what we need to analyze, this fly ash we have to analyze. In the fly ash, if more CO content is there, okay, so carbon monoxide, okay, CO content is there, so then it is incomplete combustion. Okay, so incomplete combustion. Okay, so if more CO2 content, okay, so CO2 content is there, it's a complete combustion. Okay, so complete combustion. These are the two considerations. Okay, so this we have discussed in our classes under the air pollution concepts. Okay, so air pollution concepts. There we have discussed these concepts even deeper. Okay, so but this is the simple question, so definitely they may give this kind of questions. Okay, so what we have to analyze, the fly ash we have to analyze. Okay, so from this one, if more CO content is there in complete combustion, if complete combustion it is CO2 will be present. Okay, other particles, other components also will be present, but what is more here that we need to understand. Okay, so even whenever incomplete combustion happens, CO2 will come and CO will come and other nitrates also will come, but which is more means here, so his CO will be more. Okay, so here what we need to understand, high percentage of CO content in the flue gases. So what is this flue gases? In this fly ash, flue gases will be there. Okay, that's how we need to understand. Okay, next question, economizer of boiler has main function of economizer, what it is having? Let's see the options. If you see here, heat up, heat up, heat up. Okay, economizer will definitely heat up. So what are the other things? Heat up the incoming water with excess steam. Okay, in economizer what is happening? For the boiler, so majorly three components are there. Okay, so one is air preheater, another one is economizer. Okay, so another one is, so the heat. Okay, so after whenever, so heater, whenever you send the water into this one, steam will be coming out, so then we need to send that steam into superheater. Okay, superheater. These are the three main components connected to this boiler. Okay, so from the air preheater, what will happen? Air will come inside. Okay, so from the economizer, water will come inside. From the superheater, steam will go outside. Okay, so these are the three considerations. Economizer they are asking. Okay, so we will be sending the water here. Okay, so water, which kind of water? Some pressurized water we are sending. So pressurized water, if you send like this, so we are sending some flue gases also like this. So using this flue gases temperature, this water will get even more heated. That is what the economizer operation. Okay, heat up the pulverized coal. Okay, so coal will be coming from this side. That is not a correct answer. See, incoming water with excess steam. So we are not heating the water with excess steam, we are heating with flue gases. Okay, so that's why this option is wrong, this option is also wrong. So heat up the incoming air by exhaust gases. Okay, exhaust gases only, flue gases means exhaust gases only, but in the economizer we are not heating the air. Okay, so we are heating the water. So heat up the incoming water by exhaust gases. This is the correct answer. Okay, so whenever you see the schematic, okay, so you remember, so whenever you see the schematic of steam power plant, otherwise thermal power plant, from here only 2 or 3 questions will be there. Okay, so these questions are very simple if you remember the schematic. Okay, so you need to remember entire thing. I have explained in YouTube also, there is one video of us. Okay, so you just see the entire operation of this thermal power plant, from there only you will be getting 2 or 3 questions. Okay, so easy questions these are, we should not miss. Okay, next question. So in a superheater, what is happening? So okay, in a superheater, pressure rises and temperature drops. Temperature rises and pressure drops. Temperature rises and pressure remains unchanged. Pressure rises and temperature remains the same. Okay, this is one of the previous year question also we have given in our mock test. Okay, so what is happening in a superheater? They are asking. In superheater, steam will be coming. That steam, okay, so the temperature of this steam will be increased a little bit. Okay, so that's what is happening in the superheater, but pressure will not be changed. Okay, so only temperature increases, but pressure will not be changed. Temperature rises and pressure remains unchanged. Option C is correct. Okay, so the same question I have explained in the other video also in 500 questions. So you just watch some more explanation regarding to that. Okay, so what all components are included in the annual operating cost? Okay, so annual operating cost. Okay, for this is from the economics. Okay, so when you construct the power plant, so we need to consider all these fixed charges, otherwise operating cost and the semi-fixed cost, all these things we need to consider. And whenever, so what are the components included in the annual operating cost? Okay, so annually operating cost, what will decide? See, for the entire year, so what are the considerations? What are the money we are spending on? Okay, so we need to observe from the options. Okay, So fuel, definitely, okay, so it is operating only. So whenever more output required, definitely, so more fuel we need to spend. That means more input we need to spend on this one. Okay, so that's why fuel will be varied. It will come under the operating cost. Okay, so next one is maintenance cost. Definitely maintenance cost also. Whenever the plant is in operation, at that time we need more maintenance. Some of the components like condenser needed more maintenance, and boiler. Okay, so remember one more point. Okay, so boiler needed highest maintenance in any power plant. Okay, in any thermal power plant. After the boiler, turbine needed more maintenance. After the boiler, turbine. After the turbine, we need the condenser operation. Okay, so these are the three major maintaining components. Okay, so these are the three. Anyhow, maintenance cost also will be varied month to month. Okay, and similarly labor cost. Okay, so it will be varied. Okay, so whenever you have the work, then only you will call for the labor and you will complete the works there. Okay, so this is the other option. Interest. Okay, we have taken the loan to construct the plant, so definitely interest will be coming from that. Taxes also we need to pay to the government. It may be central government or state government. Okay, so next, insurances and depreciation. Okay, so insurance, definitely it is fixed. Okay, every year, so it may be from the fixed cost it will be coming. Otherwise, every year if you want to pay anything, okay, like installments will be there. These are fixed charges only, or we can consider as a semi-fixed charges. Depreciation. Okay, what is this depreciation? So if you purchase any of the component or any of, let's say it's a boiler or any turbine, okay, you have purchased. If you use that or don't use, okay, after some days their value will be decreased. So after 50 or 40 years, what will happen? This entire value of the turbine or boiler, it will be decreased to very minimum. So you have to replace this boiler because its efficiency decreased now. So you have to replace means where is the money? Again you need to spend the money, right? It's not comes under the operational cost. Okay, so depreciation, we every year we are keeping some amount separate. Okay, so that is a depreciation cost. So whenever this boiler completes its operations, okay, then with that money you need to purchase the new boiler. Okay, like any equipment we are purchasing for the power plant, for each and every component there is certain depreciation. So every year you have to remove some of the amount for the depreciation. Okay, whenever you purchase something, so definitely depreciation will be there. So that's why from every year, okay, some amount we have to keep aside. That's also comes under semi-fixed or fixed cost only. Okay, so that's not under the operational cost. Okay, so anyhow answer for this question is fuel maintenance and cost, and fuel maintenance cost and labor charges. Okay, the next question, what is the plant capacity factor? It's a direct so definition only. So if you see the ratio of actual energy produced to the maximum possible energy. Okay, so this is the answer for this. Let's see the other options. Okay, so they will confuse with the other options. Just see the other options also. All these capacity factor, plant use factor, plant utilization factor. Okay, so then coincidence factor, diversity factor, load factor, demand factor, connected load. Okay, plant capacity, reserve capacity. Okay, so what is the cold reserve, what is the hot reserve, what is the spinning reserves? These all things we need to understand. Okay, so I told you already all these things, okay, in the classes. So just understand, write down all these things at one point. Okay, so see every time definitely one question will be there from this area. Okay, so next thing is the power system experiences peak demand from, okay, so when it will be peak demand? So it's a general question only. So from evening 6 p.m. to 10 p.m. it will be generally, so peak loads will be present. Why means everyone will go to home, they want TV, fans, all these loads will be increased slowly. Okay, so at a time everyone will be coming to the home and they will be operating all their loads. Okay, so that's why, so fans, TVs, everything will be on in the evening time only mostly. Okay, so that's why, so this some may think, okay, so industry whenever they operate from 10 a.m. industry will be starting at around 10 a.m. to the 5 p.m. Okay, so this is the industrial time. So at this time, okay, so definitely fixed load will be present, but that's not the peak load. Okay, so anyhow most of the domestic loads will be operating in this evening time only. So that's why after 10 what will happen, everyone will stop all these loads and they will be sleeping. Okay, so that's why we will consider this as the peak load. Otherwise just check our Telangana or any AP related load curve, daily load curve, you just check. Okay, so you can understand where the maximum load is coming. Okay, so next question, the power output per unit volume of MHD generator is proportional to, okay. So this is a direct energy conversion, okay. So they have mentioned in the syllabus, that's why we have given this question. We may not expect this kind of question, but just given as an example, they may give this kind of questions also, okay. So MHD generator they have asked, it's a direct energy conversion, okay. So direct energy conversion techniques these are, okay. So anyhow, answer for this question is, so what is this direct energy conversion based on MHD? Specific electrical conductivity of gas, square of the magnetic field strength, square of the fluid velocity, okay, all of this. See, what is this MHD? If you know, you can answer this question. See, MHD means, so between the two poles, okay, so continuously if you send the gas, okay, so the gases will be carrying the charge, okay. So if gas will fluctuate or gas will move very fast, so that means the carrying capacity of the charge carrying capacity of that gas, it will be more. So once the gas has to carry the charge means definitely conductivity matters there, right? If conductivity is more charge will be carried. If conductivity is less charge will be carried, okay. So anyhow, if you are our student, just check the class there. I have explained the complete operation of this MHD generator also, okay. So anyhow, answer for this question is all of the above. Magnetic field strength also matters. If field strength is more, then more charge will be transferred there, okay. Specific electrical conductivity of gas and similarly fluid velocity also, okay. So we have to use the gaseous fluid here, okay. So answer for this question is D, okay. Next question. In gas turbines, the thermal efficiency is obtained in, okay. So thermal efficiency they are asking. So high thermal efficiency is obtained in, okay. So we have open cycle, closed cycle, and so closed or open depending upon the other considerations, okay. See here. So these are the tricky options, okay. So they have mentioned both. They have mentioned either one of them according to the considerations. So here we need to understand. So closed cycle. So they are having less thermal efficiency. That's why we are connecting the. So three kind of considerations for this open cycle. One is intercooling. So we have explained this in the classes, okay. Just to check once. These three concepts, whatever I am writing here, very, very important, okay. From these three only, there will be definitely one question, okay. So intercooling is there. Another one is reheating, okay. Reheating. Another one is regeneration, okay. So regeneration. So what are these three? So intercooling we are doing at the compression time, okay. So whenever you are compressing, so no need to use as a single compressor, you can use the intermediate compressors, okay, like low pressure compression and after that high pressure compression. So in between we are doing the intercooling, okay. So this is the intercooling. We have certain advantage, okay. So just see there. And similarly reheating, why we are using this reheating? Instead of using the single turbine, we can use a low pressure turbine, after that high pressure turbine, after that low pressure turbine. Whenever you send it to low pressure turbine, what will happen? Heat may lose there. So what we will be doing? We are reheating. We are reigniting there, okay. So that's what reheating technology. So after that regeneration, okay. So the exhaust gases what are coming out from the turbine, okay. So gas turbine, so exhaust gases will be coming out. We can reuse that, okay. So if you want to reuse again, so the energy we are reusing, that means we need to keep some heat exchanger there, okay. So we are using that heat exchanger, so and converting the steam, so heat present in the exhaust gases, and we are utilizing that heat, okay. So that's what about regeneration, okay. So these are the three things. So that's why this is not a closed cycle, okay, open cycle. So in open cycle we are having these three techniques to improve the thermal efficiency, okay. So but you see one thing, why to go for all these things? Cost for that entire fixed cost for that gas turbine power plant will increase. That's why instead of going for this, we can go for the closed cycle, okay. So closed cycle. So anyhow you will be knowing, okay. So it will be working based on the Brayton cycle, okay. So Brayton cycle operation is nothing but our closed cycle only, okay. So anyhow, so this closed cycle is having more advantages and good thermal efficiency compared to open cycle, okay. See, remember, even though these three techniques we have used in the open cycle also, closed cycle is having a higher thermal efficiency, okay. So anyhow, answer for this question is closed cycle, okay. That's the answer. Next one, compressor used in the gas turbine is? Okay, this is the very simple question. If you see the class, okay, it's not understand. If you see the class, I will be giving, okay, so one compressor I will be giving like this. Okay, so here in the first slide only I have given that. Okay, so even you can see in the our YouTube also. Okay, so here certain blades will be there, here certain blades, here certain blades, here certain blades, here certain blades. Okay, so what are these? Not one compressor. Okay, here in this entire compression area we are having multi stages: first stage, second stage, third stage, fourth stage, fifth stage. Okay, whenever area will decrease, blades area also will be here, bigger blades will be there, here smaller blades will be there. That means it's compressing at different levels. Okay, first stage, second stage, third stage, fourth stage, like that. So many stages are there in the compression. Okay, so that's why it's a multi-stage axial flow compressor it is. Okay, see other options, reciprocating compressor. We are using reciprocating compressor in the IC engines. Okay, so not here. So plunger type of compressor we are not using here. We don't know this also. Okay, so screw compressor we are not using here. Different applications have. So this screw type and plunger type. Okay, so anyhow, multi-stage axial flow compressor. You see axial flow, why we are calling as axial flow? We are sending the air like this. After the air filter, what we are doing? We are sending axially. Okay, so that air will be compressed and that will be sent to the combustion chamber. So in the combustion chamber we will be firing that, and the gases produced there we will be sending into the gas turbine. Okay, so then exhaust gases will be coming according to the operation, whether it is open cycle or closed cycle. So this entire gas turbine power plant will be working. Okay, so anyhow, answer for this question is multi-stage axial flow compressor. Okay, this question is very important. Okay, so this gas turbine power plant, definitely questions will be there and remaining will be. So I have not given in this mock test, I have not given the questions from the hydroelectric power plant. Okay, in different one it will be covered. Okay, so anyhow, see all the other subjects and do revise properly. So we'll be seeing in the other session. Okay, all the best. Thank you so much.